advertisement from the neighboring router. Okay, yes, we can check show IP version 6 interface fast Ethernet 0/0. Here we can see in fast Ethernet 0/0 interface we can assign only global address, then we can enable that interface. So now it automatically generate the link local address. Here we can see fast Ethernet 80:2E0:B0FF:FE45:6D01. So this is MAC address of router 0 fast Ethernet 0/0 port. So the MAC address is show int fast Ethernet 0/0. Okay, this is an router 0 MAC address. MAC address is 00E0:B045:6D01. It is an hexadecimal, so the MAC address is 48 bit. So in that 48 bit, first 7th bit is, that means 0 indicates 0000, next 0 indicates 0000. So the first 7th bit is 0 means we can take an as 1. If it is 1 means we can take an as 0. So here we can put 1 means 02E0.B045.6D01. So the leading 0 can be eliminated. Next we can add it into that IP version 6 address link local 2E0 next B0. So totally 24 bits. The leading 0 can be eliminated. Next we can include E. Next remaining 24 bit MAC address. So this is an global address. Okay, let's we can see FF02::1. Each and every device can use IP version 6 means can join in this group FF02::2. So each and every router can use IP version 6 means can join in this group. Next we can see FF02::9. It indicates the each and every router can use RIP next generation routing protocols means can join in this group. Each and every router can use EHRP means can join in this group FF02::A. So here we can use RIP next generation, so it can join into FF02::9. Next we can see the sophisticated address FF02::1:FF45:6D01. So the last 24 bits can be included from the global IP address. So in global IP address the last 64 bit is, here you can see the last 24 bit is 45:6D01. So that can be added into the sophisticated address. So for what purpose we can use this group means in IP version 4 we can use address resolution protocol to send the packets from source to destination to find out the destination address, but in IP version 6 it does not support the ARP. So instead of that we can use this group. Okay, now we can check PC1 can communicate from network, so network 1 can communicate from network 2 or network 2 and network 3. Yes, we can check, go to that PC, so ping space can go to the PC2, so we can copy that address, copy, here we can paste. Okay, yeah, we can get replay from that network 2. Now we can get ping from network 3. So the PC4 address is we can get replay from that network 3. In this video tutorial, I will teach the concept of how to configure RIP next generation routing protocol. So first of all, we can assign the IP version 6 address on each and every interface. In each and every router, in the global mode, we can give IP version 6, then space unicast-routing, then only it forwards the IP version 6 traffic. Because in IP version 4 can be inbuilt in all the routers, but IP version 6 does not enable in router, so that's why only we can use that command. Next, each and every interface can be enabled as IP version 6. Next, we can assign the IP version 6 address, then we can apply the clock rate on serial interface. Next, we can configure RIP next generation routing protocol. So the syntax for configuring RIP next generation routing protocol is, in the global mode we can give IP version 6 space router space RIP. Next we can give the name of the RIP, so that name should be common for all the router. So here I will give Cisco. Next, exit. Then in IP version 4, if you are configuring a RIP means direct connected network can be configured. Router RIP 1. Next we can give direct connected network net ID we can give one. But in IP version 4, what are the direct connected interface? We can go to the direct connected interface and enable the router RIP. We can enable the RIP next generation routing protocol. Then it can be hardwareized.